Good morning, you all, my dear children. I am going to teach you chapter 9 of your course, Coordination Compounds. In this chapter, various topics are under study, but here two main topics. First one is IUPAC naming and bonding is especially this year. The questions will be asked from these two main topics, IUPAC nomenclature and bonding in coordination compounds. I am going to discuss about this. What is coordination compound? You know that bonds are of three types. First one is ionic bond, or you can say electrovalent bond. Second one is covalent bond, and third one is coordinate bond, or you can say dative bond. This is a special type of bond. In this type of bond, shared pair of electrons are donated by only one atom. Means both these electrons belong to only one atom, either A or B. This bond is shown by forming an arrow which is from donor to acceptor. Donor to acceptor. A is donor and B is acceptor. What is coordination compounds? Coordination compounds are those compounds which have coordinate bond in between them. Coordinate compounds like example vitamin B12. This one is cyanocobalamin. Cyanocobalamin is a type of coordination compound. Cyanocobalamin. Hemoglobin found in your blood, that is also a type of coordination compound. Chlorophyll present in green plants, this is also a type of coordination compound. And many drugs, many medicines which are also made up of coordination compounds. What are coordination compounds? Those compounds which have their identity in aqueous solution as well as in solid state. Means those compounds which do not ionize in water, they have their identity in aqueous solution as well as in solid state are called coordination compounds. For example, K4FeCN6. Here a big bracket is present. This big bracket is known as a coordination sphere, or you can say coordination entity. In this bracket, that thing is written which cannot be dissociated. Here, after breaking, we can find 4K plus, and this figure remains as such, like this, 4 minus. This one, 4K plus FeCN6, 4 minus. Means this cannot be hydrolyzed. This figure remains as such. This is called coordination entity. Take one more example. This is a type of coordination compound, NiCO4. This is also a type of coordination compound. This compound cannot be hydrolyzed because no any other atoms or ions are present here. Hence they cannot be hydrolyzed. Take one more example like CONH3 Br3. This compound gets dissociated to form, this figure remains as such, like this, CONH3 3 plus, and this 3Br minus becomes free. This figure is known as coordination entity. In any coordination compound like this, K4FeCN6. In this figure, this element is known as central metal. This is central metal. It may be in the form of atom or ion. This figure is known as ligand. Here the ligands transfer lone pair of electrons to this central metal and forms coordinate bond like this. this one is ligand, this one is central metal. Means ligand donate lone pair of electrons to central metal and coordinate bond is present in between this and this. Here no coordinate bond is formed, coordinate bond is present in between this and this. This one is central metal and this one is ligand. Here ligand form coordinate bond with central metal. The total number of coordinate bonds formed by central metal is called coordination number. Coordination number of that metal. Here see here, Fe forms 6 coordinate bonds like this. Like this, total 6 coordinate bonds are present. Hence, the coordination number of Fe is 6 here in this figure. Total number of coordinate bonds formed by central metal is called coordination number of that central metal. You can find oxidation number of central metal also. You read in class 11th redox reactions. In that chapter, I was discussed to you about the calculation of oxidation number. By putting the charges of these ions, we can find the oxidation number of this central metal. Don't confuse between oxidation number and coordination number. Coordination number is the total number of coordinate bonds formed by central metal. This one is coordination number. Okay? This is oxidation number. Oxidation number is totally different than coordination number. Okay? This one is about the coordination number and oxidation number. This one is central metal. What is central metal? What is ligand? Okay. Now I am going to discuss about the homoleptic and heteroleptic complexes. If the complex contains only one type of ligand, like this, here this one is central metal and this one is ligand. All 6 ligands are of same type, that one is NS3, then it is called homoleptic complex. If ligands are of 2 or more types, like this, in this figure, ligands are of 2 types, this one NS3 and H2O, this one is central metal, and these 2 are ligands. Means ligands are of 2 types, NS3 as well as H2O. Here 2 types of ligands are present, hence it is called heteroleptic complex. Homoleptic complex and heteroleptic complex. Now I am going to discuss about the ligands. What are ligands? Ligands are those atoms or group of atoms or molecules which form coordinate bond with central metal. This is called ligand. If the ligand forms only one coordinate bond, then it is called monodentate ligand. This ligand can form 2 coordinate bond with this one. This is called didentate, or you can say bidentate ligand. See here, Cl, Cn, NH3, H2O, these are the some ligands which are monodentate, means these ligands form only one coordinate bond with central metal. Here O, C2O4, 2 minus, ethylene diamine, this one is OX, like this CO3 double minus, etc. There are some ligands which can form 2 coordinate bond with central metal, hence these are called what? Didentate or bidentate ligands. Here one more special type of ligand is present, that is ambidentate. Ambidentate ligand. What is ambidentate ligand? Ambidentate ligands are those ligands in which 2 atoms can form coordinate bond with central metal. Here N can also form with bond and O can also form covalent bond. Means both these are same. Here that one is present, that is also present here. But here N forms bond with central metal and here oxygen forms bond with central metal. Means NO2 and ONO, these are the ambidentate ligands. One more example like CNS and NCS. These are also ambidentate ligands because C can also form bond with central metal and here N can also form bond with central metal. Okay. In my next lecture I am going to discuss about the IUPAC naming. I will discuss in my next lecture. Okay. Thank you.